All right, so we're doing parallel lines and transversals. This is part two, so I'm just gonna scroll through everything that we covered in part one. Remember, we talked about parallel lines, the symbol, arrows on them. Um, we talked about skew lines. We talked about this transversal. That's relates two different intersections. That's really important. And identifying the transversal that goes with each pair of angles is really important. And we're going to tie some of this together today because as we look at these transversals that connect the different intersections, we're going to be able to do some work here. But all of our work is going to be based on those lines being parallel. So again, we indicate that lines are parallel by putting the arrows on them. When those lines are parallel, we have a very direct relationship between the top intersection and the bottom intersection. We're going to relate those, but it only works when the lines are parallel. So you're going to see four rules, and every single one of them says if the lines are parallel. If they are not parallel, we cannot do this. And it doesn't matter how this picture is rotated, right? We can have our parallel lines going in this direction, and that's our transversal. But only when the lines are parallel can we do this. Here in the original, we're going to work up and down. In this one, we're going to work left and right. But we can only do it when we have parallel lines. If the lines are not parallel, it cannot be done this way. So let's take a look. So we have very distinct relationships. We have angles that are between the parallel lines, and we have angles that are outside the parallel lines. So if I identify my parallel lines, think about it. Angles 1, 2, 7, and 8 are on the outside. Angles 3, 4, 5, and 6 are on the inside. So we have things like exterior and interior. If we look at the transversal, we have some angles that are on the same side, like 1, 3, 5, and 7, or 2, 4, 6, and 8. They're on the same side. But we have angles that are on different sides, like 1 and 8. They're on different sides of the transversal. 3 and 6, they're on different sides of the transversal. So those are things that we want to know. Are they on the same side or different sides? And then finally, we have situations where the angles are in the same spot of their group. So look at angle 1, for example. 1 is in the top left of its intersection. 5 is in the top left of its intersection. Now remember, the intersections are connected by the transversal. 1 is in the top left of its group. 5 is in the top left of its group. So as we move forward, the vocabulary that we use is based on where the angles live. The relationship is based on parallel lines. So again, the name of the angle pair is based on where they are. The relationship is based on having parallel lines. And let's see what we mean here. In this picture, let's look at angles 3 and 6. Angle 3 and angle 6. They are on different sides of the transversal. We call that alternate. But they are inside the parallel lines, so we call that interior. So these are called alternate interior angles. The name alternate interior angles is based on where they are in the picture. Different sides of the transversal between the parallel lines. Now, looking at the bottom here, what's underlined? If we have parallel lines, then those alternate interior angles are congruent. So the name alternate interior comes from where they are in the picture. The relationship congruent is based on having parallel lines. If the lines are parallel, the angles are congruent. If the lines are not parallel, the angles are not congruent. So that's very important. If the lines are parallel, alternate interior angles are congruent. If the lines are not parallel, alternate interior angles are not congruent. Rewind that and listen to it 10 times if you have to. Look at angle 1 and angle 8. 1 and 8. They are on different sides of the transversal, so they're alternate. They are outside the parallel lines, so they are alternate exterior angles. If the lines are parallel, alternate exterior angles are congruent. If the lines are parallel, then the alternate exterior angles are congruent. If the lines are not parallel, then the alternate exterior angles are not congruent. Very strict. The name comes from where they are. Different sides of the transversal outside the parallel line. The relationship congruent comes from having parallel lines. So if the lines are parallel, then the alternate exterior angles are congruent. Again, let's look at these angles. I don't know what happened in the print. That is angle 1 and angle 5. Angle 4 and angle 8. So I'm not sure what happened there. Let's find them. Angle 1 and angle 5. We looked at these earlier. Angle 1 and angle 5. Angle 1 is in the top left of its group. Angle 5 is in the top left of its group. That's called corresponding. Corresponding means that they're in the same position. That's all it really means. They line up with each other. If we took all the angles on the top and just slid them down the transversal, 1 would land on 5. So they are corresponding angles. If the lines are parallel, corresponding angles are congruent. So 1 and 5 are congruent. We could say 4 and 8, bottom right and bottom right. I could do 2, the top right, and 6, the top right. So angle 2 is congruent to angle 6 because they're corresponding angles. Now be careful. They're congruent because the lines are parallel. They're called corresponding angles. So we have to be very careful there. The name comes from their location in the picture. The relationship is based on parallel lines. Not all corresponding angles are congruent. If the lines are parallel, then the corresponding angles are congruent. Only if those lines are parallel. And the last one, because I told you there were 4, are consecutive interior. My goodness. Sorry. angle 3 and angle 5. Well, before we had alternate interior. These are on the same side. Interior. These actually have two names. Sometimes they're called same side interior. More often they're called consecutive interior, one after the other, but on the inside of the parallel lines. Now, this is the only one that's a little different. When the lines are parallel, consecutive interior angles are supplementary. So we learned 4 rules. 3 of them say congruent. 1 of them says supplementary. The names come from their location. The relationship comes from having parallel lines. If the lines are parallel, then the consecutive interior angles are supplementary. So let's see what we have here. Angle 1 and angle 5. Remember, geometry cares about the parts. Angle 1 and angle 5. These are corresponding angles. If the lines are parallel, then corresponding angles are congruent. Well, check it. Yes, we have parallel lines. So that means angle 1 is congruent to angle 5. So 6x plus 10 equals 2x plus 30. And we can find out that that's 4x, negative 20, x equals negative 5. Again, we have parallel lines. We already confirmed that. Angle 3 and angle 6. 3 and 6. Well, 3 and 6 are alternate interior. And since we have parallel lines, alternate interior angles are congruent. So angle 3 is congruent to angle 6. 5x plus 20 equals 4x plus 15. And of course, we can go ahead and do some work. Angle 4 and angle 6. Angle 4 and angle 6. Think about what they're called. Consecutive interior. And as long as we have parallel lines, consecutive interior angles are supplementary. So we're going to take our angles and add them to 180. That's what supplementary means, 2 angles that add to 180. So we can go ahead and do a little algebra here. Just going to bring my work up. That's 11x. We're going to subtract 37. And get 143. And that means x equals 13. Okay. We've only got 2 more. Let's just do them. Angle 2 and angle 7. Angle 2 and angle 7. 2 and 7. So what are they called? Alternate exterior. And as long as those lines are parallel, alternate exterior angles are congruent. So x plus 25 equals 4x minus 5. Of course, we do a little bit of algebra here, and x equals 10. And finally, our last one here, 3 and 4. 3 and 4. What are they called? Well, they're in the same intersection, so we're not using our new vocabulary. Remember, our new terms, alternate interior, alternate exterior, corresponding, consecutive interior, they're there to link two different intersections on the transversal. These are from the same intersection. So this is actually old stuff. These are called a linear pair. Remember, vertical angles in linear pair don't go away. In a linear pair, the angles are supplementary. So we have 3x plus 15 plus 6x plus 11 equals 180. That's 9x plus 26 equals 180. Again, I'm just bringing my work. 180 minus 26 gives us 154. And we'll divide by 9. 9x, 20, yeah. Sorry, 180, what I do, minus 26 is 154. We're going to divide by 9, and it looks like we get 17.1. Okay, it is what it is. Okay, so we have our angle pairs, and when those lines are parallel, we have 4 very specific relationships. If the lines are parallel, alternate interior angles are congruent, alternate exterior angles are congruent, corresponding angles are congruent, alternate consecutive interior angles are supplementary. That only works when the lines are parallel. Okay. All right, so it looks like we're going to stop there, and we'll get some practice with it.